Hello friends, today we are going to start the question answers of the exercise in chapter 2, acid bases and salts. So today we will solve all the exercise question answer and this chapter will be completed. So guys, do like the video and obviously subscribe. Thank you. Now let me start the exercise from the first question. What is it asked? A solution turns red litmus blue. Its pH is likely to be. Here are 4 options given. Number 1 is 1, number B is 4, number C is 5 and D is 10. Now it is asked which solution turns red litmus blue. In this case we have to know that the basis turns red litmus blue and the acid turns blue litmus to red. So the basic solution has a pH value more than 7, as we studied earlier. In that study we have known that the number 7 is the normal one. Previous of 7 is acidic in nature and after 7 is basic in nature. So since the solution turns red litmus to blue, its pH is likely to be 10 and the option is option D, 10. Now moving on to the next question. Here it is asked, a solution reacts with crushed eggshells to give a gas that turns lime water milky. So what does the solution contains? Here are 4 options given. A, sodium chloride, B, hydrogen chloride, C, lithium chloride, D, potassium chloride. So to make lime water milky we need CO2, and we know that in crushed eggshells CaCO3 is present, and when the CaCO3 reacts with HCl, then we get CaCO3 plus HCl gives us calcium chloride plus CO2 plus H2O. So balancing this equation we have to put a 2 here. So the answer is B, HCl. Then moving to the third question. Now the question number 3. 10 ml of a solution of NaOH is found to be completely neutralized by 8 ml of a given solution of HCl. If we take 20 ml of same solution of NaOH, the amount of HCl solution required to be neutralized it will be. So basically 10 ml of solution of NaOH is found to be neutralized by 8 ml of given solution of HCl. So we are asked that if it is 20 ml of NaOH, then how much amount of HCl do we need? So for 10 ml of HCl they are giving 10 ml of NaOH they are giving 8 ml of HCl. So here we have been asked of 20 ml of NaOH, so we will be multiplying this. So the answer comes out is 16 ml. So the options were given: A 4 ml, B 8 ml, C 12 ml and D 16 ml. So the answer is D, 16 ml. Now moving to the next question. Which one of the following types of medicine is used for treating indigestion? So what is indigestion? The formation of acid in our stomach, which is the main cause of indigestion. So ultimately we need an antacid to remove the indigestion. Here are the answers given: A, antibiotic, B, analgesic, C, antacid and D, antiseptic. So the answer is C, antacid. Now the fifth question. It is asked that write word equations and then balanced equations for the reaction taken place. So here we are given with 4 equations. So these are word equation and we have to change it to balanced equation. Number A, dilute sulfuric acid reacts with zinc granules. What is now dilute sulfuric acid? Which is H2SO4. This is, always remember, dilute means aqueous solution. Then reacts with zinc granules, that is in solid form, and we get the reactants as ZnSO4, which is in aqueous solution, then H2 in gas form. Number B, dilute hydrochloric acid reacts with magnesium river. Now dilute hydrochloric acid, that is HCl in aqueous solution plus magnesium in solid form. We get MgCl2 in aqueous solution plus H2 as gas. Now balancing this equation, we have to give here F2. Number C, which is asked, dilute sulfuric acid reacts with aluminum powder. Now dilute sulfuric acid, which is again H2SO4 in aqueous solution plus aluminum powder, which is in solid form. Then we get Al2SO4 in aqueous solution, then H2 in gas form. Now balancing this equation, Al2 gets here 2, then SO, H2. Now H will be solved like this, and here given this, so the SO4 becomes 12. So for SO4 we need to give it 3 here. Now D is dilute sulfuric and dilute hydrochloric acid reacts with iron filling. Now for sulfuric acid, for hydrochloric acid, we are given here a formula which is HCl plus iron filling, which is Fe in solid form. Then we get FeCl3 in aqueous form plus H2. So we have to balance this again. So in Fe it becomes 3 here, so 3 chloride, so here is 2 chloride, so we are giving 3H here, it becomes 6, we are giving here 6, then the chloride becomes 6, so this is 3, then we have to put 2 here because 2 into 3 becomes 6, and here Fe becomes 2, so this is 2. Now the question number 6 will be solved in a different video because we have to do an activity there. So we are moving on to the next question, which is 7. The question is asked, why does distilled water not conduct electricity whereas rainwater does? So distilled water is a pure form of water. Distilled water is a pure form of water and is devoid species, because distilled water doesn't have any ionic species, therefore it does not conduct electricity. Then rainwater being an impure form of water contains many ionic species, such as acids, and therefore it conducts electricity. So here we come to know that the distilled water doesn't have any ionic species, so therefore it doesn't conduct electricity. And the rainwater being an impure form of water, because the rainwater is always mixed up with many impurities like pollution, like thunder, etc., contains many ionic species such as acids and therefore many more things, so it conducts electricity. So the next question, which is 8th, it is asked that why do acid not show acidic behavior in the absence of water? Because acid do not show acidic behavior in absence of water because the dissociation of hydrogen ions, means the differentiation of the hydrogen ion form an acid occurs in the presence of water only. It is the hydrogen ions that are responsible for the acidic behavior. So the answer will be, in absence of water, the dissociation of hydrogen does not in absence of water, the dissociation of hydrogen does not occur. It is possible in the presence of water only. So it is the hydrogen ions that are responsible for the acidic behavior. So the next question is, 5 solution A, B, C, D and E when tested with the universal indicator shows pH as 4, 1, 11, 7 and 9 respectively. Which solution is? So here the solutions are given as A, B, C, D, E, and the numbers, the pH numbers are given as 4, 1, 11, 7 and 9. So we have to find out which number of pH goes for which solution in the given points. Number A, which is given as neutral. Now neutral, as we know, the 7 is a neutral number, so the pH 7 is neutral, so it goes for 7D. 7 goes for D, for the pH is 7 and the number of solution is D. 7 goes for D. Now number B, which is strongly alkaline. Strongly alkaline. What is strongly alkaline? Means, and the number which shows the most basic behavior is known as strongly alkaline. So here the number highest is 11, which is associated with C. So the strongly alkaline pH is 11 with solution number C. Next, number C, what is strong, which is strongly acidic. Strongly acidic. So we know that going to this way from number 7, in denominating number we get the strongly acid. So number 1 is strongly acid, so pH is 1 and the number of solution is B. Then D, weakly acidic. In weakly acidic, the nearest to 7 will be the weakly acidic. So the nearest to 7 is 4, going this way, means going before 7. So the number before 7 is 4, which is associated with B. Then again E, which is weakly alkaline. Alkaline, we have found the strongly alkaline, which is 11, which is associated with C. Then we have to find out the weakly alkaline, the number less than 11 and more than 7. So we get here 9. The pH number is 9 and the solution is E. Now the question number 10. So equal lengths of magnesium ribbons are taken in test tube A and B. Hydrochloric acid HCl is added to test tube A, while acetic acid CH3COOH is added to the test tube B. Amount and concentration taken for both the acids are same. In which test tube will the fizzing occur more vigorously and why? So the fizzing will occur strongly in the test tube A, in which the HCl is present or added. This is because HCl is stronger acid than the acetic acid and therefore produces hydrogen gas at a faster speed, due to which fizzing occurs. So the answer will be like this. The fizzing will occur strongly in test tube A, in which HCl is added. This is because HCl is a stronger acid than acetic acid, which is CH3COOH, and therefore produces hydrogen gas at a faster speed, faster speed due to which freezing occurs. The next question which is asked that fresh milk has a pH of 6. How do you know the pH will change as it turns into curd? Explain your answer. So here we have told that the fresh milk has a pH of 6. So how will we change? How will be the pH will be changed as it turns into curd? So the pH of a milk is 6. As it changes to curd, the pH will reduce because curd is acidic in nature. So we have to make it more acidic. That is why the pH will be or the pH must be reduced. So here the answer will be the pH of milk is 6. The pH of the milk is 6 as it changes to curd. The pH will reduce because curd is acidic. The curd is acidic in nature. The acids present in it decreases the pH to form the curd. Now the next question, which is 12. It is asked a milkman adds a very small amount of baking soda to fresh milk. Why does he shift the pH of the fresh milk from 6 to slightly alkaline? So the first answer will be the milkman shifts the pH of the fresh milk from 6 to slightly alkaline because in alkaline conditions milk doesn't set as curd. So the answer will be the milkman shifts the pH of the fresh milk from 6 to slightly alkaline because in alkaline condition the milk does not set to curd easily. Then number B is said, why does this milk take a long time to set as curd? Since this milk is slightly basic than the usual milk, acid produced to set the curd are neutralized by the added base. Therefore, it takes a long time for the curd to set. So the answer will be, since this milk is slightly basic than usual, milk acids produced to set the curd are neutralized by the base. Therefore, it takes a longer time for the curd to set. Now the next question, which is 13th, which is said plaster of Paris should be stored in a moisture proof container. Why? Because the plaster of Paris is in always powder form. It is a powdery mass which absorbs moisture, which is water. So when the moisture gets added with the powder, it builds up a concrete like structure which is hard enough and which is known as gypsum. So the answer will be plaster of Paris, which is POP, should be stored in a moisture proof container, because POP is a powdery mass which absorbs water to form a hard solid known as gypsum. The formation is CaSO4 and O half H2O plus added 1.5 H2O, which gives us CaSO4 and 2H2O, and this is POP, this is added water, and we get gypsum. Then the next question, which is question number 14, which is asked that what is a neutralization reaction? Give two examples. What is now the neutralization reaction? The reaction in which an acid and base react with each other to give a salt and water, is termed as neutralization reaction. In this reaction, energy is evolved in the form of heat. This is something you also can write. So now for example, they have asked for two examples. So for example, the number one is when an acid reacts with base gives us salt plus water. This is acid, this is base, this is salt, and this is water. Then the second one, during indigestion, we take an antacid. The antacid neutralizes the excess of acid and thus gives us relief from indigestion. So the answer will be, during indigestion we take antacid. The antacid neutralizes the excess of acids and thus gives us relief from indigestion. So it will be like MgOH 2 plus 2HCl, which gives us MgCl2 plus 2H2O. Now the last question, which is asked, give two important uses of washing soda and baking soda. So first of all, the washing soda. Number one, it is used in glass, soap and paper industries to clean up this material. Then it is used to remove permanent hardness of water. Then number two, which is baking soda. The first will be, it is used as baking powder. Baking powder is a mixture of baking soda and a mild acid known as tartaric acid. When it is heated or mixed in water, it releases CO2, which makes the bread or cake fluffy. And you can also see the use of baking soda in your house also, because your parents will be preparing many things using baking soda. I guess your parents will be also able to answer the use of baking soda in household use. Then the next point will be, it is used in soda acid fire extinguisher, because here CO2 is present, for which CO2 is a very useful way of stopping fire. Thank you guys. So here I finished my chapter 2 of class 10. Hope you guys like the video. Guys, also remember that this question and answer will be much more easier if you see my first video on this chapter, which is all about the chapter 2 concepts. So guys, also watch that video because it will be useful for you. Thank you guys. Do like, share with your friends and do subscribe. Thank you.